All right, ladies and gentlemen, welcome back. We are simplifying the fourth root of 162. So I need to know my fourth roots. That's 1, 16, 81. The fourth power of 4 is 256. And I can do 5 to the fourth as well. And that's going to be 625. Now, obviously, 256 and 625 are too big. We want to know what's the largest one out of 16 and 81 that goes into 162. And as it turns out, it's 81. So that's the fourth root of 81 times the fourth root of 2, because 2 times 81 is that. So this is 3 fourth root 2. Final answer. Looking at number 8 now, we have sixth powers. So this is, again, we need to make a list of the sixth powers. That's 1, 64. 3 to the sixth power is 729. 4 to the sixth power is 4,096. Man, we're getting big fast. So is there a number that we can multiply 4 by to make 64 or 729 or 496? As it turns out, 64 is the one we want to go with because 64 divided by 4 is 16. So 16 times 4 equals 64, which means we're multiplying top and bottom by the sixth root of 16. Which means on the top I've got 81 times 16, so that's the fourth root, or sorry, the sixth root of 1,296, and that's going to be over the sixth root of 64. But the sixth root of 64 we can simplify down to 2. And so that's my final answer, the sixth root of 1,296 over 2. Again, those ones are pretty complicated there, but if you've got questions, please let me know. We'll get some extra practice in. But let's go ahead and look at the last topic for this lesson, which is simplifying radicals with variables involved. So now we're not just going to simplify numbers on the inside, we're also going to simplify any variables that are on the inside. So one thing that I want to point out is the best thing to do here is to break it up. We want to look at things individually, right? Root 64 x squared y to the 6th z to the 7th, we're going to break that up into root 64 times root x squared times root y to the 6th times root z to the 7th. If I do them all individually, it's much easier to look at it. So we go through. What's the square root of 64? 8. What's the square root of x squared? Ooh, so remember, what number times itself is x squared? Well, x times x is x squared. So x, when we multiply it by itself, makes x squared. So this is x squared directly. What about y to the 6th? What number times itself is y to the 6th? Well, y cubed times y cubed, that's the same number. And when you multiply it by itself, it's y to the 6th. So this is y cubed. Now here's a funny one. Z to the 7th, there's nothing that works because it would be z to the 3.5, and we don't want to use a decimal here. So we have to actually break this one up a little bit more because this is not divisible by 2. So this is the square root of z to the 6th times z. And the reason why I'm doing that is I can take the square root of z to the 6th, right? That's z cubed. But what about this extra z? We have a z still left over in the root. We took care of that one. That's z cubed. But this z is still inside the square root. So you know what? we just leave it there. So my final answer is 8x squared y cubed z cubed. But this extra z that didn't factor out, it's going to stay inside the root. And that's it. So notice that when I'm taking the square root of a variable, I'm pulling out squares, right? This is a square root, so I'm pulling out squares. You might notice that I really, I did this wrong. Oops, I'm sorry. This is supposed to be an x, not an x squared. I'm a failure. I'm going to ruin everybody's life because I can't do this right. I'm sorry. This is 2. You might notice that for each of these, I kind of just divided it by the root that it was, right? 2 divided by 2 makes 1. And 6 divided by 2 makes 3. And then I split this one up, and it was 6 divided by 2 to make the z cubed, and then I left the z. So let's do that same thing with this next one. Okay, I'm going to split it up. Cube root of 64 times the cube root of y to the 6th. Are there any perfect cubes that go into 64? Or is 64 a perfect cube? We have, let's see, 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4. Oh, that is. It's 4 times 4 times 4. That's 64. So that's just 4. But then we have the cube root of y to the 6th. So what number times itself 3 times? Well, notice y squared times y squared times y squared is y to the 6th. The same number 3 times. Or if you look at 6 divided by 3, you get the same thing, y squared. Taking that power divided by the root gives us that. Let's do 2 more examples, and then you've got some practice to do on this one. So the cube root of 27, p cubed, q to the 12th. I'm going to break it up. Cube root of 27 times the cube root of p cubed times the cube root of q to the 12th. The cube root of 27 is 3. The cube root of p cubed, remember, I can just take this divided by this, and if it's even, it comes straight out. That's just p. Q to the 12th, cube root, I can take 12 divided by 3, and I end up with q to the 4th. And that's my answer, 3p q to the 4th. Let's do the last one. I'm taking the 5th root of 4a to the 8th, b to the 14th, and c to the 10th. Well, do it separately. I'm going to take the 5th root of 4 times the 5th root of a to the 8th times the 5th root of b to the 14th times the 5th root of c to the 10th. 5th root of 4 I can't do, and there's no way to separate it down. So I'm just going to leave that as it is because I can't change it. 5th root of a to the 8th doesn't divide even, which means we need to break it into something that does. So that's, we can make this a to the 5th a cubed. So we've got a to the 5th, the 5th root of a to the 5th, which is a, but then this a cubed doesn't come out, so it's the 5th root of a cubed. Now we've got the 5th root of b to the 14th. Doesn't divide evenly, but I can split it up into something that does. The 5th root of b to the 10th times b to the 4th. Now the 5th root of b to the 10th, that's b squared, because b to the 10, you can do 10 divided by 5. But the 5th root of b to the 4th doesn't change, so that's going to be 5 5th root b to the 4th. Finally, this last one, it does work out nicely. C to the 10th, the 5th root of c to the 10th is c squared. 10 divided by 5 is 2. So now, how do we write our answers? Put it back together. Anything that is beneath the root stays beneath the root. and anything that's outside the root comes outside. So here's an outside, outside, outside. This is a b squared c squared. And then 4a cubed and b to the fourth, they're in the root, so I'm going to keep them in the root. Okay, I've got a couple of practice for you to try on this one. Go ahead and give those a go, and we'll see you in the next video.